What if I told you that like 1500 years ago, an ancient scientist sat down and wrote an entire, incredibly detailed encyclopedia on exactly how to predict the weather? And I mean predicting rainfall, classifying clouds, finding groundwater, even studying earthquakes. And they pulled all of this off without a single satellite in the sky, no Doppler radar, and absolutely zero supercomputers. I know, it sounds completely unbelievable, right? But this text is absolutely real. And today, we're going to be unlocking the incredible secrets of the Brihat Samhita. So I want you to imagine for a second living in a world where your entire year's food supply, literally your community's very survival, depended entirely on the highly unpredictable arrival of the monsoon. You can't just pull out your phone and check a weather app. There are no atmospheric pressure charts or climate models to rely on. Yet ancient farmers still desperately needed answers to those big fundamental questions. Is it going to rain? When exactly will the monsoon get here? Are we looking at a devastating drought or massive floods? So how exactly did we predict rain 1,500 years ago to answer these literal life or death questions? Well, before we crack open this 1,500-year-old scientific mystery to find out, take just a quick second to like, comment, and share this explainer, and make sure you subscribe to the channel. It really helps us bring more of these incredible historical deep dives straight to your screen. Okay, let's dive right into this. Here is our roadmap for today. First, we'll look at the 1,500-year-old mystery. Then, we'll meet the polymath of Ujjain and really start decoding the Brihat Samhita. After that, we'll pit ancient versus modern science, ask why was it forgotten, and finally, reveal history's next secret. All right, part 1, the 1,500-year-old mystery, surviving the elements. To truly appreciate what we're looking at here, we have to understand the immense historical stakes. For an ancient agricultural society, predicting the weather wasn't just small talk. It was literally the difference between a thriving empire and widespread famine. So scholars spent generations just carefully observing nature, looking for any clue they could find to secure their survival. And that brings us to our subject today, the Brihat Samhita. This is a staggering 6th century CE encyclopedia containing over 100 chapters. It didn't just cover basic meteorology. This was a comprehensive masterwork covering astronomy, architecture, water, and complex weather patterns. Honestly, it was kind of the ultimate civilization manual of its era. Moving on to part 2, the polymath of Ujjain, meet Varahamihira. You simply cannot talk about this masterpiece without talking about the absolutely brilliant mind who compiled it. His name was Varahamihira, and he lived in 6th century Ujjain, which was this massive, bustling center for science and learning at the time. Now, he mastered astronomy and mathematics, but he didn't just stop there. He extensively studied geography, water systems, and agriculture. And what makes him so fascinating is that unlike some scholars who just kind of isolated themselves in abstract theory, his multidisciplinary approach was driven by one very practical goal: applying knowledge to actually help his society survive. Which brings us to part 3, decoding the Brihat Samhita, 5 pillars of ancient meteorology. So Varahamihira documented 5 massive meteorological pillars to forecast the natural world. He predicted rainfall based on winds and humidity, he classified clouds by their appearance, tracked the monsoon's timing, detected groundwater via landforms, and even studied earthquakes. Let's actually break some of these down because you've got to see exactly how sophisticated they really were. Take cloud science, for example. Today, meteorologists classify clouds into distinct types, like cumulus and cirrus, using satellite imagery. But remarkably, ancient Indian scholars did something functionally identical. They described different cloud forms based on their physical appearance, their movement, and their direct association with upcoming rainfall. For example, they noted that smooth, dark clouds that resembled the color of a lotus root, accompanied by a sweet eastern wind, practically guaranteed immediate rain. This careful, structured visual observation of the sky was absolutely central to their forecasting, and it creates this fascinating parallel with modern atmospheric science. Now, this is probably one of the most surprising chapters in the Brihat Samhita. It explains these really intricate methods for locating underground water simply by observing specific vegetation. For instance, the text notes that if you see a specific type of banyan tree or a towering termite mound in an arid area, well, water is reliably flowing just beneath the surface. And here's the crazy part. While modern hydrogeology obviously uses advanced geophysics and drilling data, some of today's experts actually still rely on the exact same biological clues recommended 1,500 years ago to identify promising locations for new wells. It turns out nature's own sensors were working long before we ever invented ours.
And when it came to earthquakes, Varahamihira carefully tracked physical precursors. He meticulously documented signs like unusual animal behavior or sudden changes in water levels right before a quake hit. But, as this points out, ancient scientific works often combined empirical observation with the philosophical and cultural ideas of their time. So, while some observations were purely descriptive, other explanations naturally reflected the cultural beliefs of that specific era. It's a great reminder that historical texts were often a blend of meticulous physical observation and the prevailing cultural framework. On to part 4, Ancient versus Modern Science, Evaluating Accuracy. Okay, it's time for a quick reality check here. Could these ancient, visually driven methods actually rival the precision of modern data-driven science? Well, let's compare. The Brihat Samhita's primary method was centuries of careful, recorded visual observation using the elements of nature itself, like winds, humidity, and flora. Compare that to modern meteorology, which uses vast computer simulations, satellites, and Doppler radar. Did the Brihat Samhita predict weather with exact numerical accuracy? No, of course not. Though, to be fair, modern meteorologists with billions of dollars of tech still get the weekend forecast wrong sometimes. But jokes aside, both systems actually share the exact same core value: a highly methodical, systematic organization of natural patterns, completely driven by generations of painstakingly gathered data. Let's look at part 5. Why was it forgotten? The disappearance of a scientific treasure. So a big question is, how does a meticulous survival manual that essentially maps out the sky, the water, and the earth just fade from mainstream scientific education? Well, following its creation in the 6th century, changing traditions meant that Sanskrit texts gradually became inaccessible to the general public. It formed a massive language barrier. Later on, during the colonial era, the educational system shifted heavily to prioritize European scientific developments, completely sidelining many ancient Indian works in the process. Thankfully, though, modern historians and scientists are actively re-examining these texts today, and it's not to replace modern science, but to finally uncover and appreciate the really rich history of scientific thinking in India. And finally, part 6, History's Next Secret, Timeless Curiosity. You know, long before satellites ever circled the Earth, scholars were tracking seasons, studying winds, and searching for underlying patterns. That determination to observe and record directly connects ancient inquiry with modern science. For anyone focused on learning how we got to where we are today, this is really what you should take away from all this. Regardless of whether every single ancient idea was completely correct by today's technological standards, the underlying scientific spirit, that intense, methodical curiosity about how the physical world works, was remarkably strong and incredibly structured 1,500 years ago. So, where should our curiosity take us next? If you enjoyed discovering this forgotten chapter of scientific history, please make sure to like, comment, and share this explainer, and hit that subscribe button right now for more content. And I really want to know your thoughts. Comment your vote below for which ancient scientific masterpiece we should explore next. Should it be the Surya Siddhanta, the Sushruta Samhita, or the Arya Bhattiya? Let me know down in the comments. Until next time, keep observing and stay curious.